Hi, in this video we're going to be talking about something pretty simple but pretty important. The idea that all triangles have 180 degrees if you add all their angles together. So you can see here that this is sort of like a straight line, and we get alternate interior angles with B and 1, so B could be put up here. We also get alternate interior angles with A and 2, so A could be up here, and all three of these make a straight line. So if I've got two angles inside of this triangle and I want the last one, I just have to add these up and take it from 180 because 43 degrees plus 109 degrees plus the measure of angle 1 needs to equal 180 degrees. So 43 degrees plus 109 degrees is going to be 152 degrees plus the measure of angle 1 equals 180. So I could subtract 152 from both sides. So the measure of angle 1 has got to be 28 degrees. There we go. Okay. Let's do another one. In this one, I've got 52.8 degrees and 43.1. I got this angle 1 up here. So I know that the measure of angle 1 plus 52.8 degrees plus 43.1, all of these should equal, I ran out of space, 180 degrees. So we could say that's really just 180 degrees equals the measure of angle 1 plus these two added together, which is 95.9 degrees. Subtract 95.9 degrees from both sides. So the measure of angle 1 has got to equal, that should equal 84.1 degrees. Just doing that on my calculator here quick. So let's try a little bit more complicated example. I've got these three angles, 2x plus 5, 3x minus 1, and 4x minus 4. If I add those all together by our theorem, we should get 180 degrees. So 2x plus 5 plus the 3x minus 1. Just adding those sides together. To get one big mess of an equation, we got to solve. So 4x minus 4. There we go. So now I just got to solve all this stuff to figure out what x is. So 180 degrees equals, got 2x plus 3x, that's 5x, plus 4 more x's is 9x, plus 5 minus 1 is going to be 4. Minus 4, oh, that's just 0. So 9x plus 0, all right. Then we could just divide both sides by 9 and we're going to be done. So 20 equals x. So that is the variable that I was hunting for, but then it wants to know the measure of all our angles. So we just got to put 20 into all of those. So that 2 times 20 plus 5 is going to be 40 plus 5, which is 45 degrees. So this one over here has got to be 45 degrees. The red one, we've got 3 times 20 minus 1, which is 60 minus 1, which is 59 degrees. Great. And then we got the last one. So 4 times 20 minus 4. So that's 80 minus 4, which is 76 degrees. Cool. So we found the measure of all of our angles and we figured out what that variable was. That's it. This next theorem uses a little bit of that idea of 180. We know 1 and 4 have to be 180 degrees, and we know 4, 2, and 3 have got to be 180 degrees. And so the way it works out is that this angle ends up being the same as these two added together. So this exterior angle, this angle outside of our triangle, is equal to the two other sides added together. So if I'm looking at this example, and I want to find the measure of angle 1, the measure of angle 1 has got to equal these two angles added together. So that's just a simple 67 plus 56, which is the measure of angle 1 equals 123 degrees. And this exterior angle has got to be like a continuation of one of our sides. So see how it's sort of this big long line right there. So if we look at this next example, I'm looking for that big long line to continue out from our triangle. So this 155 is our exterior angle. So this time we can say 155 degrees, and I'm trying to figure out what this guy is. That's going to be the measure of angle 1 plus 31 degrees. So I can find measure of angle 1 by subtracting 31 degrees from both sides. The measure of angle 1 equals 119 degrees. And that's done. Finally, we're going to do a quick proof here. Using that idea of 180 degrees being in a triangle, we want to supply the missing reasons for this proof that B and C have to be complementary angles if D is making it a right triangle. So we are given that angle D is a right triangle. That's part of a right angle in a triangle. That's giving us our right triangle stuff. Since D is a right angle, the measure of angle D is 90 degrees according to the definition of right angle. Then we've got the measure of angle B plus the measure of angle C plus the measure of angle D is 180 degrees. So that's BDC. So that is the theorem that we started this video out with. The triangle angle sum theorem, which is theorem 3-19, or the triangle angle sum. Okay. Now I've got this equation and this one. So the main difference between these two is this one has the measure of angle D and this one has 90. So these got swapped out. That is the substitution property. Okay. We are allowed to subtract 90 from both sides of the equation using the subtraction property of equality. If we subtract from both sides, that is the subtraction property of equality. But after we simplify that, hey, look, we've got the measure of angle B plus the measure of angle C equals 90. So according to the definition of complementary, B and C have to be complementary. And then that's done. All figured out. The major thing I want you to get out of this video is the idea that if you've got a triangle, there are 180 degrees inside of that triangle. It comes from our parallel lines and a transversal, A and 2 being alternate interior, 1 and B being alternate interior angles. Thanks so much for watching. Bye-bye.